Hello everybody, welcome back. This is lesson 3 in our Unit 3A unit. Today's lesson is called Naming and Formula Writing of Binary Compounds. So in the last video we covered kind of the basics of ionic bonds, what it was, what it's made of, and how it is formed. And today we're going to talk about how to name formulas and how to write formulas for these binary, and binary means two, so a compound with two different pieces. So a few reminders and kind of important facts. Ionic compounds is made between a metal and a nonmetal. So later on, we'll talk about what happens when a metal and a metal bond together and when a nonmetal and a nonmetal bond together. Those exist. Those are different types of bonds. We'll get there eventually. But ionic is metal and a nonmetal. And so basically, the metal will lose an electron to form that positive ion, and a nonmetal will gain that electron and become negative. Positive and negative stick together. So if we have, let's say, Na and Cl, this electron will go over there. Sodium will lose it, chlorine will gain it. So sodium will be +1. And remember that +1 means you lost one electron. And chlorine will now have all 8 electrons and will be -1. And remember, -1 means you gained 1 electron. So positive and negative stick together, and now this attraction between the positive and negative, that is your ionic bond. Okay, so when a compound is formed, the overall charge needs to be neutral. So what that means is that the positive stuff needs to equal the negative stuff. So in our sodium chloride example, we have 1 positive 1 charge, and we have 1 negative 1 charge. So positive 1 plus negative 1 gives you 0. And as you progress through these questions, it will make more sense as we go on. So the first thing we're going to talk about is, I give you a name, you have to give me a formula. So give you a whole bunch of steps, and we're going to kind of walk through it together. So step 1 is to determine the ions and the charges. So if we give you the name, magnesium is the symbol Mg, and chloride, yes, it has an IDE ending, and we'll talk about that soon, but that is chlorine. Now, to find the charges, and again, once you do this enough, it'll kind of stick into your head, but magnesium is going to be +2. Remember, it's going to lose those 2 electrons, so that's what that positive means. It's bad. Okay. Now, for nonmetals, you'll see a bunch of different options. Now, for nonmetals, you're going to pick that top number. So for nonmetals, pick the top number. Now, all the other numbers, those are possible oxidation states, and we get into our unit called redox or reduction oxidation, those will come into play. But you're just looking at that top number, and you know that because chlorine has 7 valence electrons, it's going to gain 1 more. Okay. So now we have our charges. So let's do this. So next step we're going to do is the crisscross method. So with that, we're going to take this number, just the number 2 for magnesium, and bring it down. It's going to be the subscript for chlorine. Now, this number right here, the charge for chlorine, and again, we're just bringing the number, is going to go down to be the subscript for magnesium. So here, you're just moving the numbers. You're not moving the actual plus or minus. So if we're going to write this, it's going to be Mg, again, bring down this number, 1, Cl2. So what this means is we have 1 magnesium and we have 2 chlorines. Now, if you have a number 1 down there, you don't need to write it. Remember, 1s in chemistry are kind of invisible. So you would just write MgCl2. Now, a good way to check this, well, you should check this, because especially if we're new to this, the overall charge of your compound should be neutral, or should be 0. So if we look at magnesium, the formula tells us we have 1 magnesium, and the charge of magnesium is +2, okay? So that means magnesium is bringing a total of a +2 charge, okay? 1 magnesium ion bringing a +2 charge. Now, if we look at chlorine, our formula says we have 2 of them, and the charge of 1 chlorine is -1. So if you have 2 chlorines, each of which brings a -1 charge, that is a -2 charge. So then if you just do +2 plus -2, that gives you 0. So this is a good kind of check to make sure that you are on the right page. So we're going to go over a few more examples before I let you practice this. Okay, so let's go into some more examples. So our next example would be magnesium oxide. So the symbol for magnesium is Mg, and the symbol for oxide, again, we'll talk about that IDE ending soon. That's talking about oxygen, and that is O. So then you want to look at the charges. So for magnesium, it's that +2. It only has that one option. And for oxygen only has that one option. So remember, if we talked about oxygen had multiple options, you only pick that top number for your nonmetals. Now that we have that, let me get a different color. Take this, bring it down. Take that, bring it down. And so now you get Mg2O2. Now, we are not done. This is not your answer. What you have to do is simplify it. So you want to have the simplest ratio when you have your formulas. So we can divide both of these things by 2, and to simplify it, we just get MgO. And that is your correct answer. Now again, if you wanted to check this, and we should, for magnesium, our formula, which is right here, we have 1 magnesium, and we know magnesium gives you a +2 charge. So magnesium is bringing a total of +2 charge to that compound. Oxygen, our formula has 1 oxygen, and oxygen brings a -2 charge. And so in total, oxygen is bringing a -2 charge. +2 plus -2 gives you 0. That is correct. So that's how we know that is our correct formula. So let's do another one. Lithium sulfide. So lithium is Li, sulfide is talking about sulfur, and that is S. So for lithium, you're going to pick that top number. It only has one number, so +1. And for sulfur, again, for nonmetals, you pick the top number. And so that would be -2. So now what you do is you crisscross. So bring down that 1, bring down that 2. So you get Li2S1. Remember, this 2 came from the sulfur charge, and this 1 came from the lithium charge. Now again, you don't need to write the 1s. You can just write Li2S. And that would be your formula. So again, if we're just going to check this quickly, which you should, for Li, our formula says we have 2 of them, and lithium has that +1 charge. So if you have 2 lithiums, each of which brings a +1 charge, you have a total of +2. And then if we're looking at sulfur, our formula has 1 sulfur, and sulfur is bringing a -2 charge. So if you have 1 sulfur that brings a -2 charge, it's bringing a total of -2. +2 plus -2 gives you 0. Your formula is good. Okay, so 2 more examples. Next is calcium chloride. So what do you think the formula for calcium chloride would be? Let's just go on, use a piece of scrap paper and do what we did for these questions for the next 2. So go ahead and try this. What is the formula for calcium chloride? So you should have said CaCl2. Well, let's look into how we got there. So calcium is Ca, chloride, again we're talking about chlorine, is Cl. So for calcium, we're going to take that +2 charge. And for chlorine, again, you're only taking that top number, so that's -1. So then you crisscross those values, and you get Ca1, Cl2. Again, you don't need to write that 1, so it becomes CaCl2. And again, if you're checking it, your formula has 1 calcium, which brings a +2 charge. So it's +2. Chlorine, you have 2 of them, each of which brings a -1 charge. So chlorine in total is bringing a -2 charge. +2 plus -2 equals 0. So that is why that is your formula. If we go and do the next one, lithium phosphide. So lithium is Li, and phosphide, again, we're talking about phosphorus, is P. So for lithium, we're going to use that +1 charge, and for phosphorus, we're going to use that top number, -3. And then you're going to crisscross, and you get Li3P1. Again, you don't need to write that 1, so it would just be Li3, like that. And if we're going to check it, lithium, you have 3 of them in your compound, each of which has a +1 charge. So in total, lithium is bringing a +3 charge. And then if we're looking at phosphorus, the compound has 1 of those, but phosphorus is bringing a -3 charge itself. So if you have 1 phosphorus ion, which brings a -3 charge, you have a total of -3. +3 plus -3 equals 0. So that is how you know that is correct. Okay, so naming ionic compounds is a lot simpler. So what you have to do is identify the anion and the cation. So you have your positive sodium and your negative chlorine. Remember, this is your cation, this is your anion. We're going to name the cation by its element name. So Na is sodium. And then we're going to name the anion by its element name, but with the IDE ending. So chlorine becomes chloride. So then you have your cation first, your anion second. So your name would be sodium chloride. And that is your name and formula for the simple salt. Now, going over the names of these anions, fluorine turns into fluoride. Chlorine turns into chloride. Bromine turns into bromide. Iodine turns into iodide. Oxygen turns into oxide. Sulfur turns into sulfide. Nitrogen turns into nitride. And phosphorus turns into phosphide. Again, all of these have the IDE ending. So only the anions, so those non-metals, get this new ending. So let's try this. We have Na2O. So when we're talking about naming, the numbers here, they don't matter. We don't care about them. So Na is sodium, O is oxygen, but remember we have to turn that into its IDE ending using something from this list. So oxygen becomes oxide, and so you get sodium oxide, and that is it. So for Ki, again, we're going to follow that same pattern. K is potassium, I is iodine. But remember, we have to switch that to its IDE ending. So iodide. And then our formula, or name rather, becomes potassium iodide. Just like that. So try this one. Example number 3, SrO. So Sr is strontium. O is oxygen. But remember, we can't use oxygen. We have to change it to oxide. And so then that becomes strontium oxide. Like that. And then our last one, example 4, try this one, Ca3P2. So Ca is calcium. P is phosphorus. But remember, we have to take that, use the IDE ending, so that becomes phosphide. And so the compound's name is calcium phosphide. Just like that. And that's it. So if we give you the formula and we ask for the name, that's a lot easier. So that's it for this video. Kind of lengthy in terms of length, but it covered a lot of information with a bunch of examples. We are going to spend more time in the next coming days practicing with this. So if you're still a little confused, that's okay. The next video will cover binary ionic compounds with transition metals. So they have multiple charges and they matter. We need to talk about how to know which one you are using. So that's basically it. If you have any questions, leave them behind. If not, have a wonderful day. Bye.